hide all these bars just to get the clear option of side. Okay, so this is all
Yeah.
about that. We are just moving.
Electric flux.
Yes.
Electric flux. The number of electric field lines crossing a given area kept normal to the electric field lines is called electric flux.
Yes, just stop. It's a very simple in the sense that the electric flux is the number of electric field lines crossing a given area. That area is kept normal to the electric field. Electric field lines are over. This area is kept normal. Is called electric flux. So this is the basic definition. For easy understanding, we
Yes.
can say that if you have created a electric field lines area, and you are just putting this surface area, and through that area, that flux, the number of lines are passing through that. So those lines are called the electric flux. Second is,
It is
yes,
usually denoted by the Greek letter and its unit
epsilon E,
is Newton. Epsilon.
phi E.
E.
This is phi.
Yes.
Phi E for the electric flux, and its unit is Newton meter square per coulomb. C for the
Per
coulomb,
coulomb.
the amount of the charge. Next is the last point.
Electric flux is a scalar quantity and it can be positive or negative.
Yes. No, it's a just a little point, but it is indicating the three things which are very related or can be mixing up over there when anybody can ask that what is the nature of the electric flux? Can there be electric flux negative? So it's a lot of thinking over there that when the lines are coming over there, when we are talking about the number of lines, the area, the field, and so how these can be negative. But this single line is just stating that electric flux is a scalar quantity. And the next thing is
Yes.
that it is positive or that may be negative. So all the electric flux. So these are the three corrected, because when we are talking about the line, so everybody is very much concerned about the direction. So anybody can mix up this, that these must be the this must be the vector quantity, but here it is clearly mentioned that electric flux is a scalar quantity. The next thing is that it may be positive or negative. So whatsoever the case is, so if there is a MCQ, fill in the blanks or true false statement, so definitely this only single line will cover the three aspects of this: the scalar, the positive or negative. Now let's see. This is the what we can say.
Electric field of a point charge.
Yes. How can you explain this? Now let's see. It's your turn just to speak out or to explain these things.
There's a charge. There's a
Source
positive
point
charge.
charge
Point charge is,
placed in the
and
center.
there's electric field passing through point shield.
Two
What is
field
called?
areas. Those
The two field areas A
which
and
is
B
placed perpendicularly. These are
to
placed
the point charge.
perpendicularly. Yes, and these lines are passing through these perpendicular. So this is
Areas.
what we can see, the unidimensional or the plane figure. So here we can see that this is the point charge placed in the center. All around that there is the electric field, and these lines are coming out from the source charge, which is Q positive, and we have placed these two areas A and P perpendicular to the lines. Now, if you are just measuring the electric flux, so we will have to measure the number of lines. So from here we can see that nearer the area, greater the number of lines. And if you are going away from the point charge, so definitely you have a less number of lines. So the electric flux is depending upon the perpendicular distance between the point charge, that is a source charge, and the area which is placed perpendicular to the electric field lines. So that is all about the pictorial view which is visualized over here, which we have seen in the definition in the first slide. So this is about that. Now let's see, just going to the next one. Yes. Now let's see. This
Consider
is the
two small
explanation. So
rectangular
this slide is
area.
actually what we have
Yes,
seen the figure
explanation.
in the previous. So this is just describing the whole story point by point. So first point is just read out.
Consider two small rectangular area elements placed normal to the field at regions A and B.
Yes, just
Even
stop
though
it.
these
Just stop.
elements,
Just
yes,
why? This
okay,
is just only one point. We will have to keep one thing in mind. That is the rectangular area placed normal or perpendicular to the field at regions A and B. So the underlined word is that must be placed normal or perpendicular to the electric field, to the electric field lines. So that must be placed perpendicular. Next point.
even though these elements have the same area, the number of electric fields lying crossing the element in region A is more than in element B because
Yes. So
A
no,
is
no. Let's
closer
see.
to the point charge.
Actually, just wait a minute. Now the second point is very important one. How can you express this second one for the easy understanding? What is the second point?
because
Yes,
the
yes.
point charge, the source emits the point charges, and the closer you are to the source, the more lines pass through because the distance does not change. They just continuously, infinitely go in the opposite direction. So the further away they are from each other,
Yes,
the
you have
more
got the point.
the
So,
less area will pass through.
yes, even though these elements have the same area, the area of
Yes,
the two rectangular A and B are same. So, the number of electric field lines, that is the most important. The number of electric field lines crossing the element in region A is more than that crossing the
indeed.
elements in region B. So this is the first observation that the area is the same, but their distance from the source charge is different. One is nearer to the source charge and one is away from that. So it is totally depending the electric flux that near the point charge of the same area, you are getting the greater number of electric field lines. So the next point is,
Therefore, the electric flux in region A is more than in region B.
yes, flux mean that the number of electric field
The number of
lines.
field lines passing through.
Yes, good. So it's a in A is greater than B, although the A and B have the same area. Next.
The electric field strength for a point charge decreases as the distance increases. Then, for a point charge, electric flux also decreases as the distance increases.
So how can you explain this in your own words? Last is very simple. There is a relation
Just
between the
like
distance.
when you go further away, less
Yes.
point charge passes through you. The closer you are, the more point charge and electric flux passes through.
So we can say that electric flux is
Is the
dependable upon the distance. It's a
yes,
inversely proportional to the
proportional to,
distance. Proportional to distance inversely. When you have the less the distance, the number of line, the strength of the electric flux is greater. If you are increasing the distance, the flux is decreasing. If you are decreasing the distance, the electric flux is increasing. So one quantity is decreasing, the other is increasing. So this type of the relationship is called, or we can say, the
inversely proportional.
inversely proportional. So these are
Proportional.
the few points. So if you are just joining all these points, you will get the exact crystal clear picture about this topic, that what is the nature, what is the relationship, what the factors are depending upon these, and how much the strength we are measuring of this electric flux. So anyhow, we are just moving to the next slide.
Electric flux for uniform electric field.
Yes.
Consider a uniform electric field in a region of space. Let us choose an area A normal to the electric field's line. Let the electric flux for this case be electric flux into area.
Yes, so this is what we can say. This is the same thing we were talking about. So this is the mathematical form of this electric flux, that E is the, what
Yes,
we can say, intensity or the electric flux and area that is placed perpendicular in across the lines. The second is, let's
No,
see the second one.
area. Suppose the same area is kept parallel to the uniform electric field, then no electric field lines pierce through the area A. The electric field for this case is zero.
Zero. How
The
can you
first
explain this
consideration
one?
it is perpendicularly.
Yes.
Perpendicularly, when you go parallel, then you get, so
No
when it's
flux.
perpendicularly, it passes through. When it's parallel, they're going the same way, so they don't pass through. So they're
Yes.
going in the same direction. So
Actually,
they go side to side, but not, they don't
they
overlap.
will pass parallelly up and down, so they will
Yes.
cross without touching that area. So that's why they are saying that may be a question, when you can get the flux zero. The source charge is there, area is there, everything is the same, but you have just changed the position of that area. Now the area is parallel to the electric field line, so definitely the flux will become zero. It's a very important question that anybody can ask in viva, or any type of the question is there. So how they can say, when there is a point charge and area, and that charge is emitting a lot of electric field lines have been generated over there, so how the electric flux becomes zero? So the simple answer is, electric flux is zero when the area placed parallel to the direction of the electric field lines. The simple answer is that is zero. So one way or the other, you must have to keep this thing in mind. For the electric flux, you must have to keep the area perpendicular, and when parallel, there is no flux. Next.
If the area is inclined at an angle theta with the field, then the component of the electric field perpendicular to the area alone contributes to the electric field flux. The electric field component parallel to the surface area will contribute to the electric field.
Yes. So how can you explain, if you have got some idea? So just share.
So basically, when the point charge emits ray charge
Yes.
perpendicularly in the direction, so they overlap, the two lines
Yes.
cross each other, making an angle which is theta, and
So
then
it
they
is slightly
change.
inclined now. That area is slightly inclined to the way of where
Yes,
first it was placed perpendicular. Now it is changing
but
position,
then
slightly inclined.
yes,
So as we have
there's
seen,
an angle created,
yes, the next, just
theta.
read the next point, then I will explain a little, one point
For
more.
this case, the electric
Electric flux
flux
is
is, is
phi
cos
E
theta
is
times
equal to
the
E
area.
cos theta into area. Now
Theta times,
let's see just if we can recall the rectangular components of the vector, or if you can recall the work done by a force which is making an angle theta with the direction of, with the horizontal way in which the body is moving. So the vertical component is not coming into play. That is the sine theta of that angle. So if the angle is mentioned that this perpendicular field is placed slightly inclined to that. Now it is not a perpendicular, it is just making an angle alpha. So when you will resolve this alpha, you will have to resolve it into two components. One is a perpendicular components, and the second one is a horizontal components. The lines are moving in the line of horizontal movement. So the only component which come into play, that is the cosine theta, because sine theta
yes,
is perpendicular, and there is no way the perpendicular in this case will become parallel to those direction of the electric field of lines. So the only components is the, what we can say, the E cos theta. E is the intensity or electric field lines, and cos theta is the angle of the inclination of that field which has been placed slightly inclined to the perpendicular direction, inclined to the direction of the electric field lines, and A will remain the same over there. So that's why when the angle is mentioned, so you will have to take care of only the cosine of that angle. The sine angle will not play any role, so that will become parallel to the direction of the electric field lines. So this was mathematically what we can say a slightly different condition when you are just tilting it or you are just that placing it in an inclined position. I'm sure you have got my point. Have you got this?
Yes,
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 okay,
yes.
okay,
I
okay. Now
understood
let's
this
see, just we're going
very well.
to next one. Yes, further.
Further, theta is also the angle between the electric field and the direction normal to the area. Hence, in general, for uniform electric field, the electric flux is sine E, electric field into A E A cos theta. Here, area is the area vector, A into N,
N is
its
unit vector.
and unit vector.
Yes.
Its magnitude is simple, the area A, and the direction is along the unit vector and perpendicular to the area, just as we
So
said
this
this
was
before.
actually, these are all those points which are further explaining this, that further theta is also the angle between the electric field and the direction normal to the area. First you have placed it normal, now you have tilted down. So electric fields have the same direction, they are coming out from that source, so there is no change of the direction. But now you have slightly tilted the perpendicular area, so this is theta is the angle between that perpendicular area and the electric field lines. Hence, in general, for uniform electric field, the electric flow is just like this one, E A cos theta. We have already talked about that, where A is actually what we can say the vector that is in the area vector that is placed over there. Then the A vector, how can we calculate this direction? This direction, because now that perpendicular, that rectangular area has been placed somewhere, so it may get some direction. So that direction is just into the unit vector N. Its magnitude is simply the area A, that magnitude of that area, perpendicular rectangular area, which is slightly inclined now to the angle of theta, and the direction is along the vector n perpendicular to the area. That is what we can say, if you can be called this a vector product of two vectors. One was the scalar product and one was the second one was vector product, where we will have to put the n that is perpendicular to that product. So n is also perpendicular to the area, rectangular area, which is placed over there. So this is the pictorial view of this. So now you
Yes,
can visualize that this n is perpendicular to this slightly
electric
inclined field.
lines.
Now this is not a place perpendicular, normal. This is slightly
Yes,
inclined to the left or right. If you're looking backside, so it's a right incline. So this
yes,
n is exactly perpendicular to that field which is inclined now. So A is the area is same. So electric flux is E dot A, and N
A,
is placed when we are looking for the
unit
N, so
vector.
that we will have to calculate the cosine theta of this angle. So this was that which we were explaining in the previous slide. So here now
When
look
it's
at
placed
this.
parallelly, so there doesn't electric flux is zero because the lines don't pass through the slit.
Yes, and one thing more is that this n is now perpendicular to the lines. When the things are perpendicular, now the red lines are the electric field lines, and this small arrow is the direction of this unit vector. So these are two perpendiculars, and here you will get the cos of 90 because the angle is 90, and cos of 90 is always 0. So if you are utilizing the
Yes,
same formula cos theta and so theta is 90 and cos of 90 degree is 0. So once again, if you are putting over there in the equation, you will get the 0 due to this, because now the electric field lines are these red lines, and this is the area which is placed parallel to the electric field lines, and here you will have to get the unit vector which is exactly parallel to this rectangular area. Now the rectangular area and this line unit vector are perpendicular, and the same lines electric field lines are also perpendicular, also normal to this unit vector, which makes this angle 90 degree, and we are taking count of the cos theta. So cos theta of any 90-degree angle is 0. So when theta is 90, so cos is 0. So that's why this flux
Yes.
will become 0 all the way. Now let's see. This is one. This will be talking about the
Inclined.
utilizing. Yes. Just if you can explain. Now it's your turn to speak out.
So basically, when it was parallel and when it
No,
was
it's not a parallel.
perpendicularly, the
It's,
lines were passed through. No, but no, I'm just saying they made a
yes.
90-degree angle. Here's it's inclined, so there's no 90-degree. We have to find
The
using
angle.
cosine. We have to find the angle which has been made
E sine is
on the
parallel, so
slits
no count of that.
between the yes.
Yes. No. Let me add something. You are absolutely right. Whatsoever you are looking over there. So actually, this is the over here. The theta is over here. You can see this theta. This is the angle
Yes,
between the direction of the electric field lines, and this is the tilted. What we can say, the tilted over to the left.
tilted.
So when it is tilted, so it will make the angle this theta. Now, if you are just resolving these two parts as per the rule of vector rectangular components of a vector, resolution of a vector into its rectangular components. That was so old in the first year, the first chapter, the vectors. So when you are resolving these two parts, so one part will become sine theta and the second part will be cosine theta. It's just
Cosine.
you can just recall that formation. When you have this type of, so
Yes.
one is the sine theta will become parallel to this. There is no reaction, no way, and the cos theta is the only component which is coming into action. So that's why the electric flux is E. E is the, what we can say, the intensity or the power of all these electric field lines, and cosine theta is the tilted position of this, and A is the area of this whole rectangular area. So this is just, we can say, I think this is enough to just understand this diagram. So the next
Yes.
is
Yeah,
calculate.
calculate the electric flux through the rectangle of sides 5 centimeter and 10 centimeter in the region of the uniform electric field 100 newtons per
Per
coulomb.
coulomb.
The angle theta is 60 degrees. Suppose theta becomes 0. What is the electric? Yes. What is
Yeah.
electric flux?
Sine theta देखा, when if
So
you are
we're
making,
gonna use the formula
we will use a formula. The
EA
one thing is,
cos
one
theta.
thing that is that when the angle is 60 and when you are making it 0, what is the electric flux? When it is 0, so this tilted, it is tilted, this inclination will become the perpendicular, and you will get cosine 0 is absolute value, that is greatest value, which is 1. Cosine theta is 1, so you will get the maximum flux. Now you can use a calculator, put the sine, cosine of 60, and you will get the answer. So write in this way. Look at this solution. What we have done.
Electric flux.
Yes, that is.
Here we would use the formula A of cos theta 100 times 10 because it's centimeters to meters
Yes.
times cos theta 0.25 Newton meters and then theta is 0.5
Cosine theta,
zero
putting the
point
values.
5 Newton meters
So this is all about that.
squared per
Simple
coulomb.
mathematics. You can make use of calculator. You will get the value within the seconds. Now let's see. This one is
Electric flux is a,
in a non
electric flux is a non-uniform electric field in an arbitrarily shaped
shaped
area.
area.
Suppose an electric field is not uniform and the area A is not flat, and the entire area is divided into n
Small
small
area
area
segment.
segments,
So,
such
yes.
that each area element is almost flattened and the electric field over each area element is considered to be uniform.
So maximum of the time in physics, we are just used to divide the irregular shape to very small areas, delta areas. Those areas will become the ideally flat or whatsoever the case is. Then definitely we'll have to add all those
Very
deltas just to get the total effect of that. So we are also used to do these deltas just like this. Look at this.
electric flux for non-uniform electric field.
Now this field is not uniform. So the rays are going away. These are diverging from the point, and these are passing through very irregular shape. You don't have a rectangular shape. This shape is just like what you can say, not regular. So how you will have to get this? So you will
Whether
have to
will op-
divide this area into a very small pieces. Those pieces almost parallel, what we can say, the rectangular, just like over here, one area is shown over here. So when you will divide all these, so you will have to calculate the flux through these small areas, and at the end you will have to add all these fluxes, and you will get the net amount of the flux.
yes,
So this will be done just like this.
electric flux.
For the entire area is approximately written as,
आगे
so addition, and sigma. Well, by limiting this tends to zero. A very small, what we can say, area. That's why we'll have to make use of integration. The next one is, hello,
the total electric flux for the entire area is given by summation
integration.
E into distance
And this is a sign
integration.
of integration, that we will have to add all those flux, which are little flux for each and every small area, and then we'll have to make summation. So very useful technique is integration. Techniques of integration is used over here. So the next line is also the explanation of that. So just coming to the next one, electric flux for closed surface. Hello.
For closed surface,
Ah,
suppose a closed surface is present in the region
the
of a
non-uniform,
non-uniform electric field.
the total electric
Total
field,
electric flux over this closed
closed
surface
area.
is written as summation E times V
Yes.
into area.
One thing is, the only
Total
difference, this is also the repetition of that, but there here we are putting this sign, so we will have to limiting over there. That is absolute integration modulus, starting from this point 0 to the n is the number of all those small pieces. So this is just like that
electric
shape,
flux
closed.
over a closed surface.
So this was all the what we can say, visualize this. So we'll have to
Yes.
integrate this area into small pieces. Then after the integrating to the flux, we will get the summation of the amount of flux passes through each inch and each small area. So this was just like that. So for the more,
Yes.
what
Is
we
it
can say, only the one line is passing through that. So we can imagine this thing. We can visualize that. This is a small area throughout the figure, and only one line is passing over there. So definitely there are a lot of points, lot of these small areas, these rectangular areas where the lines are passing through. So we will have to get each and every area into account, calculating the angles, and then after that we will have to make a summation of that to get the net amount of flux, net flux. So in figure it is shown that one area element, the angle between and is less than 90, where it will become positive, or greater than 90, it will become negative flux. So that's the reason. If somebody can ask that you are saying that the electric flux may be negative, when it will be negative, so your answer statement is when the it is inclined to, or the angle of inclination or the theta is greater than 90, so it will be moving to the next quadrant. So therefore the cosine is always negative in the next quadrant. So that's why we will get the negative electric flux. So this is a good reason by utilizing the angle which is 90 degree, more than 90 degree. So this is all about that. So one thing is that I will send all these slides in the late night when I will be. So now what you will have to do the next. So all those topics or chapters which we were talking about. So you will have to pinpoint all those small topics if we have missed from any chapter. Either this may be of the first homeostasis or whatsoever the chapters are. So if you will have
okay?
to rematch, and you will have to pinpoint all those subtopics that we have not gone through those, so we will have to recover those. So I think this is all enough. So the next time you should also mention that I will look back all that your message, that what were those topics. If something is there, so definitely next time we'll come out with that. Okay, any question, anything you want to say or ask? Okay,
Okay,
okay. So you can
Salafis.
ask us and message me, text me anyway. I will. I am just sending these slides just now to your Zoom account.
Okay, thank you.
Thank you.
Salafis.
जी बेटे, पहले पापा कितने हैं? नजीर अहमद उस कमरे में बैठे हैं, वो बाहर वाले कमरे जिधर बाबा होता था। जाके चेक करके आओ, बैठे हैं कि नहीं बैठे, जिधर बाबा थे।